That only that way you can learn this software. Any software for that matter, you have to practice. And okay, let me pause this. One more time. We have a Excel, as we showed in the last class. This child mortality thing we copied from the Excel, and we paste it here. How do you paste? Here is the data editor edit. This one, this icon, data editor edit, not the browse one. Browse one will not let you type in, or you can type in also here if you want to, but here we have the file, so we copy here, copy and paste here. So we'll paste the data. If you want to paste it, they will ask how they treat the first row. As the first row as the variable. First row as the variable, then you get all the data in here. I'll erase this then. I'll close this. Is there already? Then if you want to see the variables here, what are the variables? CM, FLR, PGNP, TFR. CM, FLR, PGNP, TFR. All the variables are in here. Then you know all the functions of like sum. If you want to do a descriptive statistics, you can do summary of these variables, list, and you can do this variables. If you can say summary, and that gives you all the descriptive statistics here: mean, standard deviation, minimum value, maximum value, how many observations here. You have 64 observations, sample size is 64, not bad. You want to do scatter diagram, you can do scatter diagram. What is the command for scatter diagram? Anybody recalls?
Professor, two-way.
Two-way.
Two-way in bracket.
Then scatter in the bracket.
Scatter the variables, okay?
Yeah.
Which one? Independent first or dependent first?
First, dependent.
Dependent, okay, all right. CM. And which one you want to check? You can check each of them one by one. Let's do FLR, female literacy rate. And check.
Hello?
Yeah.
Professor, so the dependent variable should be, why is it? Because last class, what I observed is you took something from the top, like MEXP, that thing, it was in place of variable, right? So like.
So what is your question?
Like why is CM centimeter the dependent?
Why is CM?
Like why is centimeter the dependent variable?
So child mortality, I mean, that depends on theoretical economic theories, okay? Do you think child mortality depends on female literacy rate?
Yeah.
Yeah. And look at this scatter. What do you see?
A lot. a trend.
Yeah, what type of trend is that? What is the purpose of this scatter diagram? Is give you some rough idea. The relationship between CM and FLR. What can you tell?
It's negative.
It's a negative, pretty negative, almost a straight line kind of negative, huh? You see? High literacy rate, low child mortality. Low literacy rate, high child mortality. Pretty straightforward. It's an opposite, inverse relationship. Yeah, so that's yeah. So you can do that. Also, what else? You can generate, if you want to generate new variables. Can you generate? If you want to do generate a log of PGNP, what is the command? Just to recall our memories, log within parentheses PGNP. That gives you a log variable. If you want to see, you can see. How do you find the predicted values of Y? These are called point estimate. So once you regress the line, then you can find the Y predicted. Let's see. How do you find the Y predicted? You regress. You first find the coefficients and R square and all these. So regress CM on what? Let's do on all of them. Okay. On FLR, female literacy rate, PGNP, and TFR. So what is the model here? Anybody tells me the model here? Model? Econometric model. What is the model here?
Over here.
Yeah. Look at this.
CM.
CM equals
1. Sorry, CM equal to FLR or beta 1?
What are you saying?
Sorry, beta 1 plus 2 FLR.
Beta 2
FLR.
FLR plus
beta PGNP.
3
PGNP.
PGNP plus
beta 4 TFR.
TFR.
Plus U. Do we take U?
Yeah, these are all I's, CMI, FLRI, PGNPI, TFRI. So this is the model. Everybody with me here? For us as econometricians, you have to be careful about the model. Don't do it mechanically here. If you don't know the model, then it's obviously. So let's see if we can. Not found. Yeah, they are not taking this. Okay. I'll do it again. Here. Rather slow, but it's coming, don't worry. Yeah. So first thing, can we explain, can we interpret all of them, all the coefficients here? Can anybody go ahead and explain these coefficients, the numbers here? This column only. Hello? Anybody? So first one is beta 1 hat, okay? which is 168. How do you explain that?
If FLR, PGNP, and TFR, sorry,
0.
yeah, if they're 0, then on average, CM, as in child mortality, will be
168.
Yeah.
Yeah, be 168. Then how do you interpret beta 2 hat?
And holding PGNP and maybe TFR constant.
Yeah.
If FLR increases by 1 unit, then on average, CM would increase by
Would decrease.
sorry, would decrease by 1.7
on average. On average.
Yeah, on average. Yeah, I told on average.
Yeah, okay. So that is B2 hat. B3 hat, which is minus 0.005.
5.
Anybody wants to interpret that?
It's the same as like I explained beta 2, right?
Yeah, go ahead.
Holding the other 2. So over here it will be holding TFR and FLR constant if PGNP increases by 1 unit on average, child mortality rate decrease by 0.005.
0.005. And beta 4 is, which one is beta 4? TFR. So that is 12.864. Yeah. How do you explain that?
This one, holding FLR and PGNP constant. If TFR increases by 1 unit, on average, child mortality rate would increase by 12.86 unit.
Yeah, so that is like our first line interpretation of the regression.
But Professor, will be it unit or?
Yeah, unit, yeah.
Okay.
Whatever the unit is. Yeah, what is your question? What is your confusion?
Professor, I confusion was unit or other things.
What other thing? Some mysterious thing?
Like percent.
Oh, percent. Were you in my inter-micro class in the morning?
Yeah.
No, this is unit. Percent will be elastic if it is elasticity. Is it elasticity? No, it's kind of slope here. It will be elasticity if you have log type of model. Okay. So
but
let's
Professor, we already found out the scatter diagram, right? So now if I want to see the diagram, can I without doing again?
Without doing what?
The two-way scatters in the command without putting this, can I see the scatter diagram now?
Without putting what?
The command, because we already did it.
You have to save that. I did not save it.
Okay.
Yeah, any separate output you want to keep it for future reference, you save it. Okay.
Okay.
So, and then R squared. What is the R squared here? These are the key results so far as we know. R squared, coefficient of determination is 0.75, I would say. How do you explain that? Nobody wants to interpret that? Hello?
Yes, Professor.
Go ahead.
R squared 0.75 means 75% of variance.
Not variance, variation. Variance and
Okay,
variation are different.
Variation is explained.
Of what? Variation of what? Variation of
y can be explained by x.
What is y here? Huh?
Child mortality.
Exactly. You have to say in your context.
Child mortality.
Yeah. So 75% of the variation of child mortality.
Mortality is explained by CM.
By what?
No.
By what?
What is X here?
What is X? You don't know? You can't see the X's here?
Yeah, the PGNP.
Only PGNP?
Then FLR.
Then? Huh? What are the X variables here?
These three.
Yes. You have now 3 variables in the X. So how do you explain R square? This is how. 75% of the variation of child mortality is explained by the regression.
Explained by variation, FLR, PGNP, and TFR.
Yeah, by FLR, PGNP, and TFR together. Yeah, or you can say by the regression itself, because in the regression you have these 3 X variables. All right, so that is R squared. Do you guys have any questions so far? As a baseline analysis, then we can, yeah.
I have a question. Like, for example, when we look at the table, how can we understand which one is dependent and which one is independent variable?
Here. Do you see this corner?
Yes.
This is here in this corner. They are giving you the
dependent
variable, and in this
column,
they are all independent variables. The last one is the constant, means the
beta one.
Okay. Yeah, you will know each of the numbers here. Our second target is to understand all the numbers here. Okay.
Yeah.
So that's what we will be doing one by one, but you need theoretical background for that. So so far you guys are okay? Anybody got any questions here?
No.
If you are not playing with this software, you will never learn, I tell you. Faria Shamsun? Hello? Faria?
Yes, Professor.
Are you there?
Yes, Professor.
Did you install the software?
Yes, Professor.
Huh?
Yes, Professor.
Okay, please. Humaira, Himo? Himo, you there?
Yes, Professor.
Are you wearing a yellow Punjabi? Himo?
Yes, Professor.
Yellow Punjabi?
No, Professor.
No. Do you have pockets in your Punjabi?
No, Professor, I don't have. Okay,
so you are a real Himo. Go ahead, Himo.
Hello, Professor.
So you have installed the software? Huh?
Hello, Professor.
Yes, are you working with this? There is no skip. At least I'll make sure you guys at least learn the basics of data. The rest you're on your own. Anyway, so
Professor,
yeah.
Professor,
Yeah.
this is Kajuli.
Kajuli, yeah.
Professor, Professor, I send you email. I hope you got that, because right now I am unable to install this software.
Yeah.
In my mobile phone.
Yeah. If you cannot do it, I don't know. Maybe you try later on. If not, I don't know what to do. We'll decide later on. But,
Professor, I have also problem because I don't have laptop.
Yeah, if you don't have laptop, I don't know what to do. Obviously, your cell phone cannot do.
Yeah,
Can you borrow for a while and then?
That's why I'm.
Yeah. I'm sorry.
But Professor, in village area.
Hello. Yeah. Yeah.
In village area, borrowing laptop from other people.
Yeah, you borrow from others. Yeah, whatever. Yeah. I don't know what to do really. I'm sorry. I'm sorry. I don't know. Without laptop, what can you do? Econometrics is not a course to just read the theoretical part and then go home. No, this part is a very important part. Yeah. All right then. So now what else can we do? As we showed in the last class, we can do y hats. We can find all the y hats. How many observations here in this data set? Can you see? How many observations?
Professor, 64.
64 observations. If you find y hat, how many y hats will you get?
64.
Yeah, for each x, you will get one y hat. So let's find the y hats first. How do you get y hats? These are called also point estimates, point prediction, y hat, estimated y. So here you have, this is CM hat basically. So how do you get this? With this predict command. Predict, we'll call it CM hat. Is that okay? Or predicted CM. Let's call it CM hat. How many will you get? You will get, this is the command word, XB. Those who know, those who have done matrix algebra, they might remember something like this. So predict is the command word, predict. This is what you call it. I'm calling it CM hat. So basically y hat, predicted y. And this is a command word, stata, XB. So there you got the predicted values of child mortality. You can see side by side the CM and CM hat. So actual y, the values of child mortality and the predicted values of child mortality that you predict from your regression analysis. Here you see CM, CM hat. Here, all these values. How many you will get? 64. Yeah, 64 values, both side by side, so you can see the values. You can also check what? Correlation between these two. Remember, this is y, this is y hat. Correlation, anybody remember the correlation formula? I guess this is.
Yes, Professor.
Is it this?
Yeah.
The correlation between CM and CM hat. See? What
Professor,
is? Yeah.
Sorry to interrupt. I did not understand the prediction one.
Predict means y hat. How do you get y hat?
By predicting, estimating.
So you have estimated equation. What is estimated equation here, by the way? With this estimated equation, can anybody tell me the estimated equation? CM equals?
Equal to beta 1.
Yeah, what is beta 1? So CM hat equals what?
168.
168.30 plus minus basically.
Yeah, minus.
Minus 1.768, whatever the value is. And what is that? FLR.
FLR.
Yeah, I'll let it start here. So multiplication plus or minus
0.005
0.0055
PGNP plus 12.868 TFR.
This is the estimated line. Okay, estimated model. Now, how do you get, let's say, first values here of CM hat? Here, this CM hat. How did you get this CM hat? 178.28. How did you get that? If you know one, you can tell all others. This is how you plug the value of TFLR, PGNP, TFR, the first set of values from here. So here, 168 minus 1.768 multiplied by what? FLR?
37.
37 minus 0.0055 multiplied by 1817 plus 12.868 multiplied by 6.66. Then if you plug all the values of the independent variables here in this your estimated model, you get the first CM hat. You can try with your Excel sheet, or you will get whatever we got here. This value 178.28. Second value 207. How do you get 207.83? Here.
By plugging the values.
168 minus 1.768 multiplied by 22. Minus 0.0055 multiplied by 130. Plus 12.868 multiplied by 6.15. So is it clear how you get the CM hats?
Yeah. Professor, now can you explain the formula which you wrote, like the command predict CM hat?
Huh?
That predict CM hat, can you explain that command?
Yeah, that is just a predict, okay? It's just a prediction. So it's a predict is the command word, okay?
Yeah.
Then whatever you want to call it, you write it here. I want to call it CM hat, so I wrote CM hat, a comma here. Then this is from strata XB.
What is XB?
Did you do any matrix algebra?
Yes.
Yeah. So X is a matrix of all the X values. X, you know, how many X values are there?
64, right?
Huh?
In this sample, 64, right?
It's 64. How many variables there? Three variables.
3 variables.
3 variables, 64 observations, and 1.1 values for constant terms. All these values are this X matrix. So software knows there is a X matrix, which is like row would be 64 times 64 by 4, an X matrix, and with a B. What is B? B is the beta 1 hat, beta 2 hat, beta 3 hat, and beta 4 hat, that vector. So they multiply it and they find it. There is a formula for matrix formula for OLS estimators. They are using that here. I have done matrix algebra in our class in the past, but I found that it's taking a lot of time and students lose interest in that pretty soon, and it's difficult, technically difficult. It doesn't add too much. So we resort to software. Don't worry about this. So this is that formula, OLS formula, that we did summation xi minus x bar y minus y bar divided by summation xi minus x bar. Equivalent of that in when you have more than one independent variables. So that's what that is. XB. You have to write it like this. XB. You cannot write anything else.
Professor, can you just explain more the vector v, because it's with the direction, right?
Huh?
So like,
what direction? What direction it was?
So like vector v, like can you just give a more detailed
matrix? If you have done matrix algebra, you know that vector can be of many orders. This is a 4-order vector.
Okay, understood. Beta 1, beta 2, beta 3, beta 4.
No, okay. Yeah, it's a beta 1, beta 2, beta 3, beta 4. It's a 4x1 vector. Matrix, the X matrix is actually 64 by 4. So 64 by 4 multiplied by 4 by 1. What will be the that kind of this X matrix? But let's not go inside there. Okay. If you are interested, there is one chapter separately on the matrix algebra. Let me, when you ask you, let me tell you the matrix formula for OLS. I still remember. This beta head vector would be, you know what? X is the X matrix. Prime. You know prime? Do you know this transpose?
Yes.
X transpose X inverse. So yes. This is the matrix you are looking at basically. Inverse to the power -1. So this is a X transpose X inverse matrix, and multiplied that by X transpose Y. What is Y? Y is the dependent variable. So basically this formula, they are somehow putting it here. Anyways, I'm not going to spend too much time on that. So this is the predicted Y. Now you can do other things also with prediction. Residual. You know residual? What is the residual?
It's U.
Yeah, U hat. What is U hat? Remember U hat?
Y minus Y hat.
Exactly. So here in our context, what is that? CM minus? Is it?
CM minus CM hat.
CM minus CM hat.
CM hat.
CM minus CM hat. That residual can be generated also by a very important thing here, residual. Residuals can be generated by similar, either you can do this CM minus CM hat, or they will do it for you if you can write predict, you call it whatever you want to call it. I call it residuals, comma, R. They call it R. You have to write R there if you want to find residuals. R stand for residuals. Then you get all the residuals. Now you can see the residuals also. Let me list everything. CM, CM hat, and residuals. You will see side by side. So residuals are generated. Residuals, what's happening? Oh,
Professor, your spelling is not correct.
Yeah, my spelling was wrong, so I have to write the wrong spelling now. What to do? I'll copy them again and I'll correct the spellings. Remember, this is like mechanical. The software knows whatever you asked it. So my RSI, okay, I'll write there. RSI residuals. It's wrong, but I'll write the wrong ones. Yeah. So here. So you see CM, CM hat, and residuals. How do you get the residuals? CM minus CM hat. Okay. But what is the command? The command is predict. So predict you can use for two purposes here, at least so far. One, if you want to find residuals, but we know the definition of residuals is y minus y hat. Here, predict residuals, comma r will give you the all the residuals. How many residuals will you get? Hello? Huh?
64.
64. Yeah. So predict command you can use for CM hat, Y hat. Also, you can get it from for residuals. Remember, you want to get Y hat, you want to get residual, you have to run the regression. If you don't run the regression, the software doesn't know residual at all. Once you run the regression, then immediately after that, you ask for Y hat, you ask for residual, software will give you that. So without running regression, don't ask for residual or prediction. Okay. Question. Do you have any questions so far? Or else we have to move on to something a little bit theoretical.
Professor, can we get a break for prayer?
Okay, how long will you take?
5
minutes.
How long?
5 minutes.
5 minutes.
5 minutes. Okay, don't take more than 5 minutes, please. This is a class time and we have to use it. Okay, quick.
Professor?
Yes. You're back? Yeah.
Yes.
Go ahead. Any questions you?
No. I was not hearing anything for a few minutes. That's why I thought that you might have left the class or something.
You were not here? I'm sorry, I didn't get you. Hello?
I wasn't hearing anything for past few minutes. That's why.
Oh, didn't you listen? Didn't you hear that some people were asking for a break for 5 minutes?
No, actually, I didn't hear properly because my internet was going back and forth. It was loading back and forth, so I couldn't hear anything properly in the last.
Okay. So yeah, it's over now. The break's over.
Okay.
So let's get back to work. What were we doing? Now let's move on to some other areas. The goal is to explain here this outcome, okay, this strata outcome here. Actually, most important things are here. So we would like to explain the numbers here. Second thing is here, this 3 columns here, 1, 2, 3 columns. So we need some theoretical background for that. Who recalls the assumptions? What are the assumptions?
Yes.
Assumptions?
Yes, Professor.
What are the assumptions? How many assumptions we had?
Sorry, 5.
5 assumptions. Let me show you what we did. Just to remind you of the assumptions here. You see this screen, new word screen? Huh?
Yes. Yes, Professor.
First assumption is the econometric model is correctly specified. That means linear in parameter and all this. And then expected value of U, 0, variance of U is a constant value, covariance 0, and x's are fixed from sample to sample. Then you had 1, but I did not tell you 1, the number 6th one, okay? Well, we said if assumptions 1 to 5 are satisfied, then all estimators are blue, best linear unbiased estimators. Now we need a 6th assumption, okay? 6th assumption. What are we trying to do? We are trying to do some hypothesis test. Have you heard of this word, hypothesis test?
Yes.
Yes, Professor.
Or what kind of test you did?
Hypothesis. Like trialing if the assumption is true or not.
Yeah. What is an example of assumption?
Professor, it was how close regression parameters are close to population parameter.
Regression parameter, population parameter. What do you mean by this? Huh?
No.
What did you do in that probability statistics? What kind of test you did?
Like we test if it can be nullified or not.
Yeah. What is it? An example
for example, if we have a thesis and we say that smoking is bad for health.
Okay.
So
how do you test that?
Test through hypothesis, like one will be it is, and the other will be alternative hypothesis.
Okay. And then how do you go about it? How do you test that?
first we test if the thesis can be nullified, which is hypothesis testing. And then opposite of hypothesis testing is that we try to prove, and if nullified, then alternate hypothesis is proved.
Yeah.
That's what I understand.
I see. Anyways, it's a pretty general thing. But you have done a test of mean?
Hello?
Huh? Difference of means? That kind of tests? Mean or difference of means, difference of variances. Did you do using Z-score or using T-score? Speak out,
no,
please.
Professor. No, Professor, we didn't try that. T-score?
Z-score, did you do Z-score at least?
Oh, yes, yes.
To test hypothesis like mean equals something and mean is not equal something. One tail, two tail test.
Yeah. Yes, Professor. But Professor, I remember doing that in HBS, not in university course.
Not in okay. Not in probability statistics?
No, I don't remember. Maybe we did, but
no, you did.
I don't remember.
You were able to do it. I taught statistics for a long time. I know what is there in there. Anyways, so let's do in our context. You'll be doing millions of tests in this, not millions, okay, that's an exaggeration, but you'll do a lot of tests, hypothesis tests in this course. So let's start with the first type of tests, okay? So we'll go slow, and we'll be like doing in a shortcut method, because this is a place where I cannot introduce hypothesis test. You should be introduced it in the probability and statistics. So remember the model in our model in a econometric model. Let's say in our example, the of Strata, the CM equals beta 1 plus beta 2, FLR plus beta 3, and so on. Their model, or our model, the prime, our initial model. Can you see this first model we have here? Y equals beta 1 plus beta 2 xi plus ui. Hello?
Yes, Professor.
Yes, Professor.
So forget about u. Okay, u is always there. So let's ignore you. Think about it. Any econometric exercise you do, any regression you run, the second thing you do is you do some hypothesis tests. One test is generic. Always, any software will do one type of test, no matter what software you're using. That test is to check whether beta 2 is equal to 0, or equal to true for beta 1 also. So let's say beta 2 equals 0, statistically speaking. Let's start with that test. Beta 2 equals 0. So null hypothesis, beta 2 equals 0. If that is true, then what can you tell about the relationship between x and y? So first thing we are saying, if beta 2 equals 0, so you have a null hypothesis, and we will introduce null, alternative, blah, blah, all the theoretical background as much as time permits. But let's say beta 2 equals 0. What is it telling you about the relationship between x and y, ignoring u?
Beta 2 is 0.
Let's say beta 2 is 0.
Then y will be beta 1.
Yeah. So what is the relation between x and y then? If you want to draw let's say here, I'll erase that. If you have on the vertical axis y, horizontal axis x, what type of line will you get? If beta 2 equals 0, you don't have any clue?
Vertical line, right?
Vertical.
Sorry, this one, horizontal.
Huh?
Horizontal line.
Let me again put it here. So you have this model. Let me copy that model from here. These things will have to be clear. See, I cannot teach this basic linear equation, straight line kind of issues. That will be killing our valuable time here, wasting our valuable time here. Let's say this is the model. Okay. Now ignore the U. Forget about you. I'll put it in there. Now, what we are saying is, if you somehow can show that beta 2 is 0, what is it telling you between the relationship between x and y? Is the question clear, or the question is not clear?
It is clear, Professor, but I don't know how to answer.
So you say beta 2 equals 0. What do you get? You said it right. You are saying y would be equal to? Y would be equal to? Beta 1. Is beta 1 a constant or a variable? Huh? It's a constant. It's a parameter. It's a constant. So then y is also a? Is y a constant then?
Yes.
Yes. So does it depend on x?
No. Not anymore.
Not anymore. That is the relationship. Now, if beta 2 equals 0, that is telling you x does not affect y linearly. Meaning, you can say y is not linearly dependent. Linear is a linear relation, dependent on x. That is why this test is very important. But you can do any other test. If you want to know beta 2 equals 5, that test also can be done. If you want to know beta 2 equals 0.7, that's also possible. Any value of beta 2, you can test. But softwares will, if you don't say anything, softwares will test this first. Why? Because that's so important. If this is true, then your model, what you said, y is linearly depending on x, is not valid anymore. So you do everything, you run the regression, and then next step is try to do this test. So what do you need to do that test? We need to know how to do the hypothesis tests. So, so that is a hypothesis test we are going to do. Okay. How do you start with? You start with two things. What is this? Can you see this? What do you call it? What do you call it? Null hypothesis. Null hypothesis. So this is what I'm going to do. Null hypothesis. Null hypothesis. First test, and we'll be doing many other tests. First test. Null hypothesis. Beta 1. Sorry, beta 1. I'll let you do. I'll do this one. Beta 2 equals 0. What is the implication in our model? What does it mean? And I'll let you write clearly in plain English. It means y. I'll copy it from here. It means
y is not linearly dependent on x.
On x. I'm very picky about this line. because sometimes people do it mechanically, doesn't know what they are doing it for. Then alternative.
What is null hypothesis? I didn't get.
Don't ask me that. Did you do probability statistics?
Yeah, that's why I did null something, but I forgot. There was just
you lost them. Alternative hypothesis. I'll write HA, or you can say H1. I'll tell you what null hypothesis. Doesn't matter. Beta 2 is not equal to. Now I don't know how to write it. Is not equal to. I think there should be some. Let's see. Somewhere there should be some not equal to sign. I'm trying to find not equal to sign. No. So in that case.
So you can insert.
Huh?
Insert you can find symbols.
What is that?
Insert, like beside home there is insert.
Yeah,
so
yeah, I know. I'm looking for that. Yeah. Insert, yeah.
Or write equal to and press ABC, that cross ABC.
Yeah, you know the DOS command for that?
Yeah.
Huh?
It's here only, Professor.
Equal
to, and then select equal to and press ABC.
Press
beside
ABC.
Underline.
Huh?
It's beside underline on top, like file paste over there, beside bold, italics, underline. There is one ABC cross.
Here,
beside this, this one. Yeah. You need to press, like select equal to sign.
Oh,
press that.
Select equal to sign and
press this.
Oh, I see. I see now. Thank you. Let's see if it works.
It should.
I'm not sure. Not working. Somebody suggested something else. Let's see.
Professor Manisha copy pasted in the chat box.
Manisha, thank you.
Yeah, she did.
Yeah. Thank you.
Yeah.
Yeah. Because this is important here. It's not equal to sign. That's why I'm looking for that. Okay, who asked what is null hypothesis? Oh, now what's happening? Oh no. Okay. I know. Oh yeah. What's going on here?
Yeah. Now it won't happen.
Yeah. Okay. Yeah. So somebody asked, what is a null? What is an alternative hypothesis? Okay, let me try to. What does it mean? It means. Okay. Null and alternative actually started. If you go back to the history, they were trying to say this is what we are trying to nullify. Okay. Now somebody was telling you want to nullify something. So you have a mind to nullify this hypothesis. So you are putting it in the, if you're calling it null hypothesis, doesn't matter what you, as a researcher, you really don't want to nullify or rectify anything, okay, or rectify anything. You just want to know whether beta 2 is 0 or not. So let's say you starting with this hypothesis that beta 2 is actually 0. Now, whatever the evidence tells you, if the evidence tells you that beta 2 is 0, then what to do? If your evidence tells you that beta 2 is not equal to 0, then whatever. As a researcher, you have to be objective. But what is important is you have to have, now listen carefully. I don't know what you did in the probability statistics. So this is your last chance of learning these hypothesis tests. Even though I'll be doing it in a shortcut method, there are two methods. So when you are trying to test whether something is true or not, then you resort to hypothesis. Now, number one, please listen carefully. You always do hypothesis test on population parameters. What did I say? Hello? Hello? You always do hypothesis tests. You always test on population parameters. What do you use to do that test? You use the sample statistic. You never do test on sample statistic. Never do test on X bar, sample mean, or if you do test on population mean, you use sample mean to see the truth about population mean. Never test sample statistic. Will you remember this? Hello? Can you hear me?
Yes.
Yes, Professor.
So
Yes, Professor.
what did I say? I cannot emphasize more.
We have to do hypothesis testing on population parameters. We cannot we cannot hypothesis testing. We cannot do hypothesis testing on sample.
Never ever. Actually, you want to know the truth about population parameters, but nobody has seen the population parameter, okay? So what do? You want to know the truth about population parameter, then you use the sample evidence, like sample mean and all, sample statistics, sample estimators. These are all coming from sample. So what is the estimator of beta 2? Huh?
Beta 2 hat.
Beta 2 hat. So when you are trying to test the population parameter here, beta 2, whether it's 0 or not, what do you use? Use the
Beta 2 hat.
Yeah, sample statistics, sample, I would say sample evidence. So general evidence, estimator here, estimator. In our case, estimator, beta 2 hat. Somewhere you have beta 2 hat here. So I'll use this. So you have estimated, you have beta 2 hat. You use that one to test whether beta 2 is 0 or not. Now, I'm going very slow. Please, if you have questions, you ask. So two hypotheses here. One is a null, another one is alternative. These are all population tests on population parameter. Using sample statistics here, estimator of beta 2. Now, regarding these two hypotheses, once again, they have to be mutually exclusive and exhaustive. Do the words ring a bell? Huh? Do you remember these words? Huh? These two hypotheses have to be which two? These two. Number one, mutually exclusive, meaning whatever the value you have here cannot be in the alternative hypothesis. Whatever values you have in the alternative hypothesis cannot be in this hypothesis. There cannot be any overlap. So think about these two hypotheses. Beta 2 equals 0 and beta 2 is not equal to 0. Is there any overlap? Any intersection between these two?
No.
Huh? Hello. Are you guys there? Are you there?
Yes, Professor.
So these two hypotheses, are they mutually exclusive? Mutually exclusive means the value you have in the null hypothesis.
Yes, Professor.
The value
Yes.
you have in the null hypothesis cannot be here in the alternative hypothesis. Or whatever the values you have in the alternative hypothesis cannot be in the null hypothesis. So that means mutually exclusive to each other. So you see, beta 2 is 0. That is the null hypothesis. Alternative, beta 2 is not equal to 0. That means there is no overlap. The 0 value is not in the alternative. But the other values other than 0 is not in the null hypothesis. What are the other values other than 0? Huh? Beta 2, if you say, what are the other values other than 0? What are the other values? Can you guess? Hello? You guys are keeping quiet. What happened? Think of a real line.
We don't know the answer.
Think of the real line. In the real line goes from where to where? Huh? Minus infinity to
Plus infinity.
Plus infinity. All the values, think about it. In the null hypothesis, what value do you have? 0.
0.
Alternative hypothesis, anything else. Starting from negative infinity to plus infinity.
Positive infinity.
Positive infinity. Only 0 cannot be in the alternative hypothesis. In that way, they are mutually exclusive. They are also exhaustive. Why? Exhaustive means all values in the real line are in this two hypotheses. All values are included. When you think of both hypotheses together, can you think of any other values that's not in either null or alternative?
No, Professor.
So all the values are included when you consider both the hypotheses. That's why these two hypotheses are mutually exclusive, at the same time exhaustive. Any value you talk about is either in here or in there. Okay.
Yes, Professor.
It's the first time you're doing hypothesis test. That's why I'm taking some time. Later on, it will be like your bread and butter you do. Then you resort to your sample information, sample evidence. First evidence is beta 2 hat. When you estimate, do you have beta 2 hat? In our this STADA, you get one beta 2 hat, which is the FLR, the coefficient of the FLR, or coefficient of this beta 2. You got this value. Then what else do you need? You need a test statistic. That's the thing we spend so much time on, Z-score and all these. Remember Z? Test statistic. I'll try to do Z, and if Z is not possible test statistic. A Z. What is a Z? Here in our context here, variable minus mean divided by standard deviation of the variable. Remember that? Variable
yes,
minus expected value of the variable. And a lot of you made mistakes in that. Divided by what? Divided by what?
And
Standard deviation of the variable. Now, in our case, what is the variable here? Which one is the variable?
beta 2 hat.
Exactly. That is the variable we are focusing on. That's the variable we will be using. When you are testing beta 2, you are using beta 2 hat. Beta 2 hat. Minus mean of the beta 2. What is the mean of beta 2 hat?
Beta 2.
How do you know?
You told me earlier.
Do you know that?
Yes. Yes, Professor.
How?
It's a rule, right? You
It's
told
a
us
rule?
in the other class.
It's a rule?
No, because like the estimator of beta 2 is beta 2 hat. So that's why the mean of beta 2 hat is always beta 2.
They'll not estimate expected value of beta 2 hat.
Yeah.
Yeah, we already proved that. Here, expected value of beta 2 hat equals beta 2. Implies beta 2 hat is an unbiased estimator of beta 2. That's why, if it's not unbiased, these tests are not valid. This thing will be all invalid thing. So that's why we have proved that the beta 2 expected value of beta 2 hat is beta 2. So and then next line we can write is, this is the test statistic. Really very precisely we are trying to do in a very simple way, even though the simple way is not simple enough. What to do? Beta 2. I did not write beta 2, so I'll write beta 2 here. And divided by what? Standard deviation of what?
Beta 2 hat.
Beta 2 hat. So this is the statistic ideally we are looking at. Then we go back, and if you go back, we have found that variance of beta 2 hat equals sigma squared divided by summation xi by x bar whole squared. So standard deviation would be what? What will be the standard deviation?
Sigma divided by summation of xi minus x bar.
Just square root of this, okay? Square root of equals square root. How do you write square root? This, whatever it is, I'll write this divided by this to the power. It looks clumsy. If I could write to the power half, okay? Or you don't like this? This is what you are actually looking at. So anyways, I'm not gonna go deep in that. Our software will do that. but at least you know what should be here. Divided by this. So Z is this. Now, Z equals I don't think I can finish it by today. This is one test. Now I need one more lecture to show you.
Professor, don't do hurry because we also have to understand, right?
Yeah, so if you have a question, you ask. I don't have any intention to be in a hurry, okay? I'm not here to just finish the syllabus somehow. So far you have a question? Huh? Or everything is lost? This part you should understand, that this Z is a variable minus mean of the variable divided by standard deviation of the variable. And we applied it here in our context. Our variable is the estimated beta 2 hat. Mean of beta 2 is beta 2. Mean of beta 2 hat is beta 2 divided by standard deviation. We did not derive the standard deviation. We said standard deviation, if variance is this, standard deviation is obviously square root of that. Question? Huh?
No, Professor.
No questions.
Professor, you put equal 2 times y.
Okay. So I'll erase one. So if we know,
Professor.
Yeah.
Why are you like putting square root?
So if variance is something, what is the standard deviation of that?
Square root of variance.
Root over sigma.
Okay.
Huh?
Professor,
yeah, Professor.
In the last line.
Here, if is the variance, what will be the standard deviation?
Root over, Professor.
Yeah. So didn't I do that?
Yeah.
Huh?
Yes, Professor. You put power half, so it's root.
Yeah, that is the square root.
Yeah.
Yeah, I don't know how to do the square root. That's why I gave to the power half. But it is equally, it's same. No, I'm not going to ask you to find these formulas and all this, but at least you should have some sense what is going on. So basically what you are trying to do is you are trying to find a test statistic, and later on you will ask, why, Professor, you did all these things. I did all these things to let you see how they are doing the hypothesis test. I'm not sure what you have learned in the probability statistics, and not everybody did HBS. So it's important for you to see how you do a hypothesis test. Once you have the test statistic, really it's easy to do the test to see whether beta 2 is 0 or beta 2 is not.
Professor,
yeah.
Did you put the like power half for standard deviation and beta 2 hat for both?
No. Look at this bracket. Do you see this bracket?
Yes.
So what is it on?
Only beta 2 hat.
Beta 2 hat? What do you mean beta 2 hat?
You put the power
only on this summation xi minus x bar whole squared. I put square root on this. Don't worry about these things. I'm just saying, if this is the variance, what is the standard deviation? Huh?
Root over.
Yeah, root over is that. So what is bothering you here? Tell me if you have any question here. If this is true, is it true? Huh?
But Professor, it seems like you put a root over only for summation of x minus x bar square.
Yeah, that's true. So what is wrong with that? Tell me. I mean, you have some confusion, I can tell. What's wrong with that?
So variance is sigma square, right?
Yeah. No, this is the variance, the whole thing. Variance of, huh?
Okay, now got it.
Variance of beta 2 hat equals sigma square divided by summation xi minus x bar whole square. So
Professor, you also put the root over for sigma square, but you cut, so it will remain like only sigma, and then divided. So yeah, now I got it.
Okay. Yeah, don't worry about those things. But are you following this step here? What we are trying to do? That we are trying to find a test statistic which we'll be using to test whether beta 2 is 0 or not. Now, test statistic, the natural candidate is Z. Okay? And how do you get Z? It's a standardized variable. You get it from variable minus expected variable divided by standard deviation of the variable and blah, and then you do, and you end up here. Do you know beta 2 hat? Yes, you estimate, you get a value for beta 2 hat. So how you go about it? You regress, you get a value for beta 2 hat, you plug it here. Beta 2, nobody knows beta 2. So what do? In one method, you plug this value of null hypothesis here. So that is so-called shortcut method. So one value is you put whatever you are testing here. So beta 2 hat minus 0 divided by sigma divided by summation xi minus x bar whole square. You know summation xi minus x bar whole square. When you were estimating, you have these values. The problem is this sigma. What is sigma?
Professor, standard deviation.
Of what? When you say standard deviation, it must be coming from some variable. Which variables standard deviation is that?
U.
Huh? Exactly. This is
So for U, it was sigma square.
That is the variance. So what is the standard deviation of U?
Oh, yes.
Yeah, see, once variance and standard deviation, you know, they are like one is square root of another or one is square root of another. So no worries. Variance of, so basically sigma square is the variance of U. That is a problem. Why? Why is that a problem? Assumption number. Variance of U given xi is sigma square, a constant. So we need this to do the hypothesis test. What is sigma square? Variance of U. Is it population variance or sample variance? Is the population variance. Do we know it? No.
Yes. No, Professor.
Population variance is not known. Population mean is not known. Population variance is not known. That is a problem. So here I pick it from here. Copy. That is the problem you are facing now, and we have to resolve that problem. The problem is sigma square is not known. So what to do? Can you do Z? If you don't know this thing, you cannot do. Cannot do Z. Cannot use Z. Okay. So what do you do? Now, here, I'll finish it up in 5 minutes. Here, you want to do this test, then this is not possible. Z is not possible. Also, is Z a normal distribution or what?
Normal distribution.
Z is normal. Z will be normal only if beta 2 hat is normal. Okay? Because you see here, this is the only variable here, beta 2 hat. Z equals beta 2 hat minus beta 2, which is a constant, and standard deviation is also a constant here, a population parameter. So this beta 2 hat, if beta 2 hat is normally distributed, Z will be normally distributed. Beta 2 hat will be normally distributed if assumption number 6 is satisfied. Do we talk about assumption number 6? Have we talked about that? No. We had talked about 5 assumptions. Assumption number 6 is U is normally distributed. This is the 6th assumption you need. So, never forget this. So, let me summarize, and from there we will be doing this test. Once you estimate the model, you have beta 1 hat, beta 2 hat, beta 3 hat, beta 4 hat, estimated line, predicted values, and all this. Then you want to know actually whether beta 2 equals 0 or not, beta 3 is equals 0 to 0 or not. That kind of hypothesis you want to know. You actually want to know whether there is any linear relationship between X and Y. So this is a test you must do, and any software will do that test for us, but we just want to know what they are doing. And to do that test, you need one more assumption. What is the assumption? The assumption is our random term U is normally distributed. Now, normal distribution means, you know, a lot of things. Mean, median, mode, and same values. Is a symmetric distribution, goes from minus infinity to plus infinity. Everything applies. If U is normally distributed, then obviously beta 2 hat is normally distributed, because beta 2 hat is a function of U. If beta 2 hat is normally distributed, then you can have a Z distribution, because Z is also a normal distribution. But we cannot use Z because the variance of U, sigma square, variance of U, sigma square is not known. So we cannot use Z, the Z statistic. And then in the next class, we will say we will be using T. Remember, we talked about T at one point. Students, T.
Yes, Professor.
So we will be using students T distribution. Instead of Z, we will be using students T distribution. And next class we will be learning T, and you be ready with your tables. We'll show you the table, T table. C table we already know. Now we will resort to T tables. But why we are doing T? We are doing T because we cannot resort to Z. Why we cannot do Z? Because sigma square is not known. So we will be using T, which will avoid using sigma square. T will be using something which is known to us. So that's it for today. We are really heading toward hypothesis tests. We will be actually doing hypothesis test in the next class. I will be showing it in the also in the software, how you get the values of T and how you interpret that and so on. But you have to know the theoretical background, how to do T tests. And later on, you will see that you will do T, you will do chi-square, you will do F, a lot of tests you will be doing. But basic structure will remain the same. So please go ahead, read the book and try to understand, or you go check your lecture notes from your probability statistics to see how you do the hypothesis tests. Anybody recall type 1, type 2 errors? Anybody there? Just remember something little bit about type 1 and type 2 errors. I guess you did it in a very abstract way. But anyways, we'll do as much as we can. All right then. We call it a day today. You have a question?
Professor.
You have any questions? If not, I can finish it up here. Huh?
Questions.
No questions. Okay. Let's finish this course. Try to practice with data sets. Any data set is fine. All right. Bye.
Thank you, Professor.
Yeah. Thank you.